This was how I climbed up and down from the roof rack of my 4Runner. I know, not the most ideal way. Now with 2 kids, I'm not getting any younger as a dad. So yeah, I need to look out for the kneecaps. Hi, I'm Ratha Sochenda, and in this video, I'll take you through my process of how I built this ladder from scratch. My goal for this ladder build was to have it match the rest of the 4Runner and make it secure, as I may be using it as a secondary anchoring point for a future project. Before I know exactly what to build, I need to see what else is out there. More often, there are already pre-made ones that I could buy. But if you're like me, you enjoy the process of building things. This process normally involves searching on Pinterest and YouTube to curate the images I like best. Doing this step helps me set a general direction for the project. From there, I start out by creating a basic master sketch in SolidWorks. Once I'm happy with the CAD model, I'll create a 2D drawing that includes a cut list for the steel, a list of hardware, any key dimensions, and cutout templates. Basically, it would be a roadmap that helps me preview where I start to where the project will end up. I started with the top and bottom mounting plates. This would help determine my upper and lower limits for the side rail. For the bottom bracket, I made it so it would hook under the lip of the liftgate. This involves using a few steel angles and steel plates welded together. Since some of the steel angles didn't come in certain sizes that I needed, I used a piece of rectangular tubing and modified it to get the 2 size brackets. Instead of using the angle grinder, I decided to switch it up and use my horizontal bandsaw. Not sure if it was any more accurate, but it was cool to experiment. Because I needed the lower bracket to sit flush, I used a grinding bit to get into tight spaces to remove enough of the inner welds and edge. I gave it a quick test fit, and you can see I used 3 bolts to help spread the load when securing it. Next was to finish the components of the top mount. I started off by getting a rough angle measurement of the curve, then created a 1-to-1 template to get a layout how it would look and help determine placement for the upper bracket. This would also hook in the same way as the bottom, but additionally be secured with double-sided tape. To make the plate, I started off using some steel sheet. I measured and marked out the bend line. After getting the sheet bent, it needed to go a little bit further. I threw it in my table bias and sandwiched a piece of steel between it while I clamped it to my desired angle. Because of where it needed to be placed, it interfered with the hinge of the liftgate. I marked the area where I needed to shave some metal off. This part is actually not done yet, but I'll show you later in the video where this picks up again. So before I even start bending stuff, one cheap way to kind of get a template is use PVC pipe. I've seen other videos, they use the hanger, they use cardboard. I wanted to use a template to better match the end product. This is 3/4 PVC. This is gonna help me get my angles and my lengths, because as you know, DOM's pretty expensive. So wanted to use an alternate cheap way to prototype before I start bending this guy up. So how this works is I start out with 2 pieces of PVC pipe. Then I 3D printed this 2-piece adjustable elbow that inserts into the pipes. This allows me to rotate the tubes to create the desired angle. I guess you can look at this like a homemade angle protractor. Then I connected the 3rd piece of pipe and so forth. trimming and adjusting the angles of the pipes so that it follows the contour of the liftgate. I made sure to space the ladder about 4 inches from the body from where I would step. This allows enough clearance for my feet to comfortably climb up. To clear the spoiler, I put a scrap piece of 1/4 inch plate in between. Then once I was happy with the PVC mock-up, I laid it flat on my table to measure the angles. I used 2 1-2-3 blocks and a digital angle finder to record the angle. Then went back into the CAD model to update the angles in the sketch. To get the first tube length, I measured the tube end to the center of the axis of rotation, or I guess to the center of the bolt. And then repeated this step from the center of the bolt to the next. Now that I have my angles refined and the distance from each tube, I plug those values into the 3D sketch. Then turn each connecting point into 3-inch radiuses to match the centerline radius of the bending die I would be using. I know I'm cheating a bit by using the software to calculate the distance needed after each bend is made, but I'll link a video in the description on how this could be done manually to achieve the same results. Now that we have all that figured out, time to bend up some round tube. I use my trusty JD Model 2 tube bender made by JDsquared that I modified to allow me to bend in the vertical position due to the limited space in my home garage. But most importantly, the bend quality is amazing and looks professional. This is the same type of bender I used when I built my rock sliders and roof rack. Before I would bend the second tube, I brought it over to see how it aligned with everything. I felt pretty good and bent the second rail and trimmed it to match. Because I care about aesthetics, I took it one step further and moved in the left railing to follow the contour of the liftgate in the horizontal. To protect the forerunner from weld sparks, I use a welding blanket. I spaced the steps about 10 inches apart from one another. Now with everything tacked in place, it was time to burn it all in. To attach the top part of the ladder to the liftgate, I marked and drilled to help me locate where the 2 threaded stud posts would need to be installed. To provide a clean weld up, I grinded off the mill scale. Then scribed in crosshairs to later help center the studs. To make them weldable, I used my belt grinder to round and shorten the head of the bolt. This will allow for a clean pathway for a fillet weld. Then, ironically, this bad boy showed up in time. It's the Lincoln TIG 200. Not totally necessary for welding in the stud, but would provide a smaller weld profile than my MIG welder. Added some tap holes as I would later secure it with screws together with the double-sided sticky tape. After the stud was welded on, I ran into issues fitting up the top plate with the top mount of the ladder. I came up with 2 options that could work. Simply drill a larger hole or create a dimple around the hole. Now option 1 would work great, but would allow some slack around the stud, which could cause the ladder to shift over time. I know I can torque the bolts down and that would help, but it also puts a lot of stress on the welds. Now option 2 would work better as far as function, but takes some experimenting since I don't have the proper tools to make a dimple. If you're like me, I appreciate the challenge and took the road less traveled and did a little experiment. I got some tubing to provide the backing and some scrap plate that a hole already drilled out. Then used a socket to act as a die. Then brought it over to the press. Once I was satisfied with the results, I moved over to where I would need to do this on the ladder. To attach the bottom part of the liftgate, it's sort of like how we did the top. You can see I left about a 3/8 gap. This is so that when I bolted it down, the ladder actually squeezes down tight to the liftgate. I then clamped it down, then drilled and tapped the holes. I chose to drill up and through where it's centered with the round tube. I also forgot to film this, but I also went ahead and drilled 2 holes through the bottom of the plate into the liftgate to have a place where I can bolt it down, then made a backing strip to bolt it to. To finish it off, I scuffed and wiped down the parts down with acetone and applied my favorite can of Steal It. After a few days of letting the paint cure, it was time to get everything prepped for install. For the areas that would get the 3M double-sided tape, I wiped it down with alcohol and heated up the surface to help promote better adhesion. After that was out of the way, I moved on to installing the top plate. Then installed the ladder. Because of the additional weight of the ladder and my already worn out liftgate shocks, the liftgate had struggled a little bit to come up and stay up. I got some aftermarket replacements and they seemed to do a better job. A little slow after it had reached a certain point, but I was satisfied to have it clear my head and stay up in the up position. After all that, this is how my 4Runner looks like with the new ladder. Aesthetically, I think it complements the roofrack. It gives it that more off-road look, I guess. And it's super sturdy, which gives me confidence that it will be secure. But most importantly, I can easily climb up to my roofrack, which will help make it easier to load and unload things, especially when the family and I go camping. As always, I hope you found this entertaining and it gave you some ideas or tips. And if you're wondering, sure, I could have bought a pre-made ladder versus making one for about the same price I spent on materials and time. But if you're like me, I simply enjoy building stuff. I actually enjoy the process and the challenge. If you have any questions about anything in the video, leave me a comment and I'll do my best to answer it. As always, I appreciate you watching. See you in the next one.